Hello everyone, so in this video I'm going to be finding for the length of the curve or the arc of this parametric equation. X is equal to t minus 2 times sine t and y is equal to 1 minus 2 times cosine t when t is between 0 and 4 pi. So what you need to know is that the formula for the length of an curve or an arc is the integral from b to a. So like in this case, b would be equal to 4 pi and a would be equal to 0. And we're going to take this integral of ds, and I'll explain why. Because if we just have like, okay, so I'm going to use a different color since the ink is almost running out. Let's just say that we have a random curve like this, and we want to find the length of the arc. Let's just say this part. Then what we would do is so this length here is equal to dx, so this length here, and this length will be dy. That means that using Pythagorean theorem, we'll have this length, the hypotenuse, as the square root of dx squared plus dy squared. And we're just going to say that this is equal to ds. And so that's why we're taking the integral from whatever interval we're trying to find the length of the curve and of ds. So that's why this is the formula for the length of the curve. And I'm going to go ahead and erase this. Okay, now I'm going to just put everything in. ds would be equal to, like I said, this the square root of dx squared plus dy squared dt. But since we're going to be integraling in terms of t, we're going to have to divide dx and dy by dt. So this is what we'll have for the length. Okay, now let's put everything in that we know. We'll have the integral from b to a, and b is equal to 4 pi and a is equal to 0. And ds, which is equal to square root of this whole thing, and dx divided by dt is equal to the derivative of this equation, and we'll have 1 minus 2 times cosine t, square it and add the derivative of this equation, which would be dy divided by dt. So derivative of this, and we'll have 2 times sine t squared and dt. Now we're going to just simplify this a little bit more. We'll have the square root of, let's square 1 minus 2 times cosine t. We'll have 1 minus 4 times cosine t plus 4 times cosine squared t, and add the square root of 2 times sine t, which is 4 times sine squared t. Okay, now let's take a look at this part. We have 4 times cosine squared t plus 4 times sine squared t. This is a trigonometric identity, and this would be equal to 4. So if we replace this whole thing with 4, then we'll have the integral from 0 to 4 pi of the square root of 1 plus 4, which is 5, minus 4 times cosine t. Now you can't really integral this by hand, right? And it's not like we can simplify it anymore, and that's why we're going to have to use a calculator to approximate the answer of the integral. And oh well, I don't know where my calculator went, but if you do integral it, then you'll get approximately 26.7298. So this would be our answer if we use the calculator to approximate it. Okay, so thank you for watching. This would be the end of the video, and in this video I explained to you guys how you can find for the surface area of this parametric equation when t is between 0 and 4 pi, and I also explained why the formula for the surface area is the integral from a to b of ds, which is equal to the square root of dx divided by, well, just dx squared plus dy squared and a dt. Thank you for watching, everyone. Please subscribe.